Welcome to week number 3 of Systems at Scale 2021 Spring Edition. My name is Francois and I am an engineering director at Facebook. This week we will focus on the topic of workflows. First, we will have Dan and Girish who will cover how we use workflow to drive automation at scale at Facebook. In the second part of the session, Maxime from Temporal will address the topic of designing workflow engine from first principle. Enjoy the talk and let's meet back right after for the live Q&A.
Hi, I'm Dan Shivitz. I'm coming to you live from lovely Gray, Seattle, and I'm a software engineer at Facebook. But in 2013, I wasn't at Facebook. I was at a small e-commerce company, probably not the one you're thinking of, working in the warehouse division. They were just starting to hit the hockey stick part of the growth curve when traffic was really starting to take off. And so naturally, we were spending a lot of our time refactoring their software monolith into a series of distributed services. Now, this had a lot of good effects. We could scale the services independently, we could version them separately, we could write them in different languages, use different backends. But when things went wrong, it was hard to figure out what the problem was. If a customer ordered a t-shirt and got a pair of socks, it wasn't clear if the problem was with the inventory system, with the conveyor system, or with the shipping system. What we eventually came to realize is that what we cared about were high-level processes that spanned across services, but all our metrics gave us were oriented at the service level. In 2013, I couldn't figure out how to reconcile these two, but in 2021 I can, and the answer is workflows. Today, my colleague Girish and I are going to talk about what workflows are and why they're cool. We're going to do a deep dive into 2 workflow systems at Facebook. And then finally, we're going to talk about what's next for workflows at Facebook. So let's get right into it. So this is not a picture of the warehouse that I worked at, but it's especially not a picture of the warehouse that I worked at when I started. Because then we didn't have the conveyors, we barely had any racks. It was mostly people just carrying boxes from one side of the warehouse to the other by hand or by foot or whatever. But of course, as business scaled up, we added more racks, and then we added more automation. We added first regular conveyor belts and then conveyor belts with motors. Because of course, we all know intuitively that as your traffic goes up, you have to automate because that's the only way to keep up with demand. And we also all more or less know that that goes for software as well as for hardware. As your system scales up, you have to automate more processes, i.e. you have to write more workflows for things that were previously done manually because otherwise you can't keep up. So one simple thing, since this is the at-scale conference, is that scale drives workflows. It forces automation, and automation of processes means workflows. But here's another thing. Let's talk about workflows operationally. So here's a generic workflow, but since this is a warehouse, you could say step A is the customer orders something, step B is you print out a label for it, step C is the inventory system gets updated somehow, and step D is you put it in a box and you put the label on the box and you ship it off. And you roll this out and it works fine. But then you discover, oh wait, actually sometimes the label printing doesn't work the first time, so we have to retry a couple times. And then sometimes the inventory system goes down, so we have to go to the backup inventory system instead. And then we want to know how long each step takes, so we know how many times we print out a label or how often it takes. And so we add timing information everywhere. And then we have to do some central logging. And before long, our nice clean business process, the only things we really care about here are the A, B, C, D, but we've had to add in all this other stuff to make it reliable. So why are workflows framework cool? Because it takes this and turns it into this. It provides a clean separation of the business logic that you actually care about from the operational logic that's necessary to make it work reliably at scale. All the security, the retries, the logging, everything else that's required. And this separation isn't just for aesthetics because it looks nice on the slide. By the way, I tried to get the designer to make the previous slide look messier and she said it was a violation of her professional code of conduct. But it's not just an aesthetics thing, right? Having the workflow separation like this makes it easier to modify and makes it easier to understand. So there's real business benefit to doing it this way too. So this is why workflow frameworks are cool. But let's talk about Facebook workflows. So we did a survey of the workflow landscape at Facebook. We found more than a dozen different workflow frameworks with a wide variety of customers. Some workflow frameworks were only used by a single customer, the teams themselves. They weren't really in the workflows business, but they were forced to build a workflow framework because they needed one and they didn't have one available. Others were used by up to as many as 1,000 other customers. The number of workflows created per day varies wildly, between 10,000 and 2 billion. The number of steps in the workflow varies between 10 and 100,000. The number of hosts executing varies between 200 and 250,000. And the duration varies wildly as well. Some workflows are sub-second. Some workflows take weeks or even months. And then finally, some workflow systems are specialized. At a previous at-scale conference, we talked about FB Learner, which is a machine learning specific workflow framework that has operations do back propagation now. Another workflow framework like this is SVE, which does video encoding that has nodes that are specialized for different kinds of things to like break up a video into segments and then do processing on it. So when we did this survey, we saw both challenge and opportunity here. Obviously, if lots of teams are doing the same thing, there's an opportunity to condense that, pull the work out that they're doing into a separate team that's focused on that, and let them concentrate on the things they actually care about, which is usually not maintaining the workflow framework. But there's also challenges here. Because the workflow frameworks and the needs of the customers are so different, you need a powerful and flexible system that can handle all these things. And so with that, I'm going to hand it over to Girish. She's going to talk about one of the largest workflow systems at Facebook and do a deep dive into its internals.
Thank you, Dan. Hi, this is Girish. I'm a software engineer at Facebook and I work in the asynchronous computing team. I'm based in Facebook Menlo Park. Today, I'm working from home, as with many of us in this pandemic. And if you hear any background noises from my daughters crying or talking about it, something, please bear with me. While at Facebook, I've had opportunity to work on a couple of systems that were presented in at-scale conferences so far. Async, which was presented in summer of 2020, is an asynchronous computing platform at Facebook, and Fox is a distributed priority queue at Facebook, which was featured a couple of weeks back in this edition of at-scale conference. The reason I bring this up is I'll be referencing these systems from my talk, so it will be nice to know this in background. While I was preparing for this conference, it made me realize how common workflows are in our day-to-day lives. Preparing for this conference felt like a workflow. A lot of things needed to happen, like preparing the blog post, preparing the talk, reviewing it with the relevant people, keep iterating it till the feedback is addressed, and then getting it ready for the final presentation. It looks like our workflow succeeded, and I'm ready to talk about this workflows at Facebook. So in the previous section, Dan covered the need for why we need workflows. And in this section, I'll be talking about a story of a couple of workflow systems that we have built in our team over the last few years, what they offer, how they work under the hood, and then what success stories they have enabled for developers. These systems are called Async Workflows and DAG. You'll notice that I use the term DAG in a bunch of places, and they are used in a couple of contexts. One of them is the DAG service, which is the system that I'm covering in this case study. And the other one is the DAG, which is directed acyclic graph, used to represent the workflow structure under the hood. With that, let's dive deep into async workflows and DAG. Let's start with an overview of async at Facebook. Async is an asynchronous computing platform at Facebook, which is a fully managed platform and offers developers ability to write a function and invoke it asynchronously. Its architecture consists of a client which schedules jobs to the API service called Submitter, which enqueues jobs to a distributed priority queue called Fox. The dispatchers dequeue jobs from Fox and then dispatch them to the workers. The overall value proposition of async is powering developer productivity and efficiency at Facebook scale. Let's talk about async workflows. Similar to how async lets users write a function and schedule it, and then the system runs that function asynchronously, async workflows lets users schedule a DAG of functions or directed acyclic graph of functions, and then system runs those function calls in the way that the DAG has specified by obeying the dependencies between nodes in the DAG. This is also a fully managed offering where developers are kind of like just writing functions and do not have to do any heavy lifting of the infrastructure itself. Let's talk about what is DAG service. Fox, which is the distributed priority queue, lets producer applications enqueue items to it, and then consumer applications dequeue items from it, process them, and call ACK or NACK API to say that they are done processing or they want to requeue these items for processing. The reason to reference that is DAG provides a layer on top of Fox, which provides dependency management functionality, where producers can enqueue DAG or directed acyclic graph of items, and then the consumers can continue consuming the items in the same way that they do with Fox by dequeuing the items, processing the items, and ACKing or NACKing the items. This system lets other teams build applications on top of it, which power workflow processing needs. Let's look at what a typical workflow run looks like. And then before that, let's go over what APIs these systems offer. Both these systems, async workflows and DAG, provide ability to create a DAG, add nodes and dependencies to the DAG, and be able to get the status of the DAG or retry the DAG or cancel the DAG. In case of async workflows, the nodes are async jobs, and when I say run, they are actually executing the user function. In case of DAG service, the nodes are actual items in Fox, and when I say run, they are being offered for processing to the consumers. Let's look at an example DAG and then go over it. As you can see, user has included a DAG consisting of steps A, B, C, and D. This color gray means they are not yet processed. System notices that the step A does not have any dependencies and it enables it for processing, so it turns green. Once step A has finished running, it turns blue, and then steps B and C are enabled for processing, or they are run because they no longer have any dependency. Their dependency A has been resolved. Once steps B and C are finished running, step D is enabled to run. While it is running, it can add another step to the workflow, say step E, and mark it dependent on the step D. So step E will not be run till the step D finishes running. Once it finishes running, step E is marked as enabled or it's run, and then the workflow finishes. Let's talk about some use cases and success stories on these systems. One of the common use cases on async workflows is creating a workflow which processes n number of jobs in parallel, followed by n+1 job once these n jobs are finished running. An example application which was able to onboard to this platform is Workplace, which is our enterprise application for companies. One of the common use cases is bulk importing contacts into Workplace by company admins. Here, they model this workflow as n jobs, each of them processing a chunk of the contact list, and followed by some post-processing, such as sending the notification of completion of this processing. The key point to note here is before this offering existed, this Workplace enterprise application was building the workflow framework on its own and doing a lot of heavy lifting to be able to manage dependencies, track the status of the workflow, track its and be able to retry or cancel the workflow. By building the async workflow system, we are able to greatly simplify their life and then provide a fully managed solution which they could use. Let's look at a success story on the DAG service. Our distributed video encoding pipeline SVE uses DAG service now for processing the video encoding application. So their workflows typically consists of video segments which are processed in parallel, followed by some post-processing which is run after that, such as stitching those video segments together or sending out notifications. The SVE team had custom DAG management infrastructure before they onboarded to DAG, and by onboarding to DAG, they were able to offload the infrastructure to the DAG service, and at the same time simplify their system, make it more reliable and efficient. This is, by the way, a very latency sensitive use case where it cares a lot about latency between processing steps, and DAG service has a lot of optimizations to enable that. Finally, another success story I would like to talk about is the system which does backfill of data in the data warehouse. This team was about to build a system to run backfill workflows on top of the data warehouse data, and at the same time they noticed that we are building this DAG service and we're able to leverage it to build a system which can do admission control and prioritization of backfills. They benefit from the functionality of Fox, such as prioritization, retry support, so that they can perform custom checks for making sure that backfills do not overuse resources, and at the same time the most urgent or important backfills get to run. Now that we have gone over some success stories of how the systems made our developers productive, let's look into the internals of the systems and look at how much effort it takes to actually build these systems. So the DAG service, as I said, builds a dependency management layer on top of Fox. It uses MySQL databases to store information about the DAGs, the nodes, and the dependencies. The actual nodes or items are stored as queue items in Fox, as these DAGs are getting built. These items are stored in a special mode called disabled mode, so that they are not offered for processing to the consumer yet. They are till their dependencies are resolved. As the DAG service notices that certain items have their dependencies resolved, it starts enabling them in the Fox service. As consumers consume these items and they are done processing, DAG service gets notified about the processing completions by polling a special topic in Fox, and then it adjusts the state in the MySQL databases. The DAG service uses a system called Shard Manager, which is a system at Facebook for enabling horizontal scalability. This was a system discussed in previous at-scale conferences to be able to scale across multiple DAG hosts and be able to assign shards to those hosts. As of today, DAG service runs 2 billion workflows a day, and then it has seen this growth in a very short time. Let's go over async workflows, which is an application on top of the DAG service. And let's see how easy it was to build this application and be able to power a general purpose workflow system for Facebook developers. So in the first slide, I referred to the async architecture. And then the only addition here is instead of submitters submitting jobs, individual jobs to Fox, here submitter submits the directed acyclic graph of jobs to the DAG service. And then the dispatchers are able to continue dequeuing these items from Fox and then sending them to the workers. We won't get into a lot of details here, but this signifies how easy the DAG service makes life of developers to build applications on top of it. Today, async workflows runs around 10 million workflows a day. Let's talk about the authoring styles of these workflow systems and look at how they are used in actual production. So you will notice that the workflows that are created in the systems can be modified in several different places, like the code scheduling the workflow, or the code executing workflow steps, or external events which are interacting with the workflow. We refer to this authoring style or model of workflows as decentralized orchestration or decentralized workflows because it provides flexibility to the user to interact with the workflow in a decentralized way. At the same time, we do realize that this makes it harder to understand the workflow structure and debug it. In the next section, I will hand it over to Dan, who will talk about CWS, another case study in this talk, which takes a different approach to authoring style and addresses these challenges. Take it over, Dan.
Thanks, Girish. And it was hailing here just a minute ago, but with the slide transition, it seems to have stopped hailing. So I guess I'll take that as a good sign. So Girish left us this teaser about centralized versus decentralized orchestration. If you remember back to the beginning, we talked about some of the benefits of the workflow framework being more understandability, more flexibility and modification. And it turns out that doing the refactor to separate out the business logic from the operational logic unlocks a further possible refactor where you centralize the business logic. Now, why would you want to do that? Isn't centralization bad? Well, let's take a look. So in decentralized orchestration, all the workers actually have two things that they can do. One is that they can do the thing you told them to do. They can execute some step and carry it out. And the other thing is they can tell you what they'd like to have happen next. So they might say, oh yeah, you're executing step D. I'd like you to queue up step E and F to be executed. So it turns out in practice what this means is if you want to understand what the workflow does, you have to look at the code of every single worker because any one of them could change the workflow at any moment. In a centralized workflow model, instead, we introduce a new kind of worker that just handles decisions about the workflow. We take away the responsibility and the sort of privilege, I guess you'd say, of making decisions about what happens next in the workflow from the workers and move it into this decider worker. And at the same time, the decider worker is not allowed to carry anything out. It's only allowed to say, this is what I want to have happen next. And then a regular worker can pick it up. So if you want to know what happens in the workflow, you only have to look at the decider because that's the only place where decisions about the shape of the workflow is happening. Now, this might seem like a sort of equivalent transformation that doesn't give any benefits, but it actually does. Look at this. If you, instead of feeding in real workflow events from the workers, you instead feed in synthetic events, you can run the same decider code and see what it would do in those situations. So if you want to say, what would my decider do if task A returns first and then task B returns second? Or if task B returns first and task A returns second? Or if task A returns and task B never returns? All the things that are hard to test in distributed systems, all the race conditions, all the timeouts, all the outages, all the errors, are easy to test if you fit them into this model. And it doesn't have to be purely synthetic events either. If you have a workflow that fails in production, you can take the event stream from that workflow. You can run the same workflow code on your dev server. You can feed in that event stream. You can reproduce a problem on your dev server. You can fix it. You can write a test case using the synthetic events mentioned earlier. And then you can push out the fixed code to production and restart in production from the same event stream. So there's a bunch of benefits to this orchestration model. And wait, there's more. So having the immutable event stream itself is cool. All the data that you need to make up this immutable event stream that says like this task started at time X, this task finished at time X, turns out are really good for things like timeline visualization. So we can generate this timeline purely automatically from the event stream that we already have. And like, you probably can't read the text here, but it's actually easy to look at this timeline and see what happened. The top bar is a workflow as a whole, so you can see it ran for a while and finished successfully. You can see underneath it, as soon as it started one task, which finished successfully. As soon as that task finished successfully, it started 2 more tasks. As soon as the first one of those finished, it started 2 more tasks. Of those 2, the first one ran, failed, paused for a while, and then was retried. The second one ran and was timed out, presumably because the workflow finished as soon as the first task finished, right? So you get all sorts of neat things from this event system. Now, if you're used to thinking about things at scale, you might be saying, isn't it expensive, all these workflows, all these events that you have to maintain? And the answer is, yeah, it's kind of expensive. There are a few techniques that we can use here. Some workflows just don't run for that long or don't run that many events, and those we don't really have to worry about since we can clean up the event stream as soon as the workflow finishes. For other workflows, we can switch to more of a sort of like parent-child-grandparent workflow, where we can clean up the events for a child workflow as soon as it finishes. So the parent workflow then sort of has more quota space to go off and run more children later on. And then finally, there's a technique we developed called event pruning. It turns out you don't actually care about all the events in all situations. Consider this piece of code. You can see it sort of runs a task, then it does a loop, and each time this loop iterates, it's going to run another task and do another sleep, both of which are going to add more events to the event log. And then finally, it's going to run a third task after the loop exits. Now, for the correctness of this code, we don't actually care about previous iterations of the loop. We only care about the most sort of immediate iteration of the loop. So for event pruning, we can pull that iteration out into its own thing, and then we can call it with this special prune events wrapper, which says basically, run this iteration, and then as soon as you're done running this iteration, discard any previous iteration. So with this in place, this workflow can now run essentially forever and will never run out of events. We'll never sort of fill up its events quota because each time it runs, it can discard any previous parts of the run. Now, this technique is super useful, and a combination of the things I've mentioned so far will accommodate most workflows, but not all workflows. For instance, some workflows need to start, say, 10,000 tasks running in parallel, and our system just can't cope with that kind of load, and we can't use event pruning to clean that up, because of course, like that's running in parallel, and event pruning essentially only works on things that are running in serial. So we got to talking with Girish's team, and we started wondering, isn't it possible to get the best of both worlds? Can't you get all the observability, all the understandability, all the modifiability benefits, but also get like great scale and flexibility? And then too, like we've had some customers ask us like, hey, do we have to go to the centralized orchestration model? For whatever reason, they didn't want to refactor their existing code. It was inconvenient or unwise for them to refactor their existing code to fit into this model. And they really did need to have sort of more of a decentralized orchestration model. So can't we have a system that, again, is the best of both worlds, that can support different models of orchestration and give all the benefits of both? So I'm going to hand over to Girish, who's going to talk about what's next for workflows at Facebook.
Thank you, Dan. So far in this talk, we have covered why we need workflows. We have gone over a couple of workflow systems, their success stories, and then the effort and complexity involved in actually building and running them. In this section, we'll take a survey of the workflow systems that exist at Facebook as of today, what we are doing to actually consolidate them and reduce like our effort duplication and also power developer productivity in future. So as we are building these workflow systems, we also realize that there are so many other workflow systems at Facebook, and then that is causing a problem. There are developers trying to figure out which system is suitable for their needs, and then there are these teams which are building these workflow systems, which are kind of repeating the efforts needed to build and run these systems. There are several examples. There is FBJE, which is powering Python workflows at scale. There are CWS, async workflows, and DAG, which were covered in this case in this talk. There is enterprise workflows, which is powering enterprise applications within Facebook, and then there is SVE, which is the distributed video encoding pipeline. With the presence of so many systems comes like higher developer confusion and effort duplication. We have made some progressive consolidation efforts over the last year or so, and where we are at today is we are migrating FBJE onto CWS, enterprise workflows into async workflows, and we have migrated enterprise workflows onto async workflows, and we have migrated SVE to use the DAG service. This has definitely helped with reducing the duplication of efforts part. But how about the developer confusion? It is still there because they still are dealing with like 3 different general purpose workflow systems like CWS, async workflows, and DAG. So what do we plan to do about that in future? So here is the goal we are setting ourselves. We'll build a unified workflow system, which would be able to cover all the use cases of async workflows, CWS, and DAG, and additionally support majority of other workflow needs at Facebook. This unified workflow system would use infrastructure which is well established like async, Fox, and DAG. As with many things at Facebook, the journey is still 1% finished. We still need to figure out a lot of details related to user experience for this unified workflow system to serve diverse set of customers, how to best leverage the infrastructure from async, Fox, and DAG, and how to migrate customers of existing workflow systems over to this new system in a reliable and a smooth way. That said, we still believe that having a general purpose workflow system would greatly enhance developer productivity, and then this consolidation effort would help us do that in addition to reducing the effort duplication and standardizing the use of workflows at Facebook. I hope you enjoyed the talk and the lessons we had. Thanks for watching.